Join DerbyCon. Today we're going to talk about GIA, Attackers, Hunting System, Admins, and what we can do about it. So I'm Lee Holmes. I'm a principal security architect at Microsoft. I was a developer on the PowerShell team since V1. Wrote the PowerShell cookbook and have been doing all the security stuff. So if we haven't met, feel free to come up and chat after. I've also got some PowerShell stickers going to be given away after, so come on by, I'll give them out. So in case you weren't up on current events, we've all seen the news of all the breaches and all that kind of stuff. But the thing is, things are getting much, much worse. They're not getting better. When you have people coming in to do pen tests and stuff, a lot of time there's all these crazy rules that say, hey, no physical ops, no phishing, none of that stuff. It's kind of off the table because it's too easy. But those rules, they don't apply to attackers. We got to figure out a way to prevent ourselves, protect ourselves from these kind of things. So let's talk. The tale of two resumes. On one side, we got the Fortune 500. They've got, if anybody can defend their systems, it's these guys. They've got huge, huge budgets, well-trained security staff, and the motivation to get things right. When you talk about this as an entity, really, as an entity, 12.5 trillion in revenue, 945 billion in profit, 17 trillion in market value. That's a lot of stuff to lose if you don't pay attention to your stuff. And on the other side, we have Benjamin Delpy. He wanted to learn C and C++, decided to share his first project. That's a pretty good hello world if you ask me. So we know how this guy ended, right? How have these, the most financially motivated companies in the entire world, how were they compromised so thoroughly, and obviously not by Benjamin himself, but by his minions, right? Because they do something that people do every single day. They said, hey, you're an admin. And he said, oh, thanks, you're done. So you've heard of elevation of privilege vulnerabilities. It's pretty common. This is a execution of privilege vulnerability. You gave somebody some privilege with the hope that they would never use it in a bad situation, but here we go. And of course, you get the keys to the kingdom when you're an admin. And here's the thing, this isn't all like mystical stuff. Like, as the Snowden stuff demonstrated, we've got governments, we've got APTs, we've got a bunch of people who are like, why am I going to go in the hard way and like burn ODAs and stuff, when instead I can just go after the admins? They're the ones who've got the keys to the kingdom already, and I'm just going to go in through them. The big thing to realize here, when you're talking your threat model, your admins are your attack surface. If you're spending your time and money only on sort of infrastructure and network defense, there's a huge blind spot that we can work on at resolving. So you might be saying, like, Lee, are you nuts? Are you saying we get rid of admins? We can't get rid of admins. And of course, I'm not saying that. A bunch of us here are admins, enjoy our jobs. I don't want to see badness go on this place. So of course we need them. But here's the thing. People make mistakes. They're sometimes bad actors, but they're always part of your attack surface. And when you're doing security, you figure out ways to reduce your attack surface. So let's talk about a situation. And in fact, we had a partner team who was very, very, very familiar with PowerShell remoting and kind of the GIA principles that I'm going to talk about today. We asked them as part of Windows Server, like, what would be a thing that you would love if we could do in Windows Server? And they were like, you know, I would love it if you could get rid of admins. This brutal, huge role that can do anything, that's a bad thing. And I said, like, you know what you do full-time job with reducing attack surface online, why aren't you just reflecting that inside? So wouldn't it be great if people didn't need these global, broad admin privileges to do their jobs? And when they did, if one of these machines got popped, you didn't have this RDP situation where you're leaking all these huge value creds that then become pivots to other systems in this keychain that you just walk around with, breaking into everything. And even still, what if people could do the things that they were supposed to do? Nothing else, just the stuff you want them to do and just the stuff they're supposed to do. Now, when things don't go right, it'd be also great if all this stuff was logged. So let's take a look at this fantasy scenario. You got Benjamin in the pot of gold. Tries to RDP into a server, of course. Decides to spew some creds everywhere. Access denied. You locked down RDP because you're smart and you don't want these things going everywhere. And he says, Jeffrey, I need to be an admin on this. Jeffrey, I need to be an admin on this server so I can restart DNS. That's a simple thing. Restart DNS. Let me do it. And he says, no, just use PowerShell, connect to the server, you're going to be fine. I don't want your creds spewed all over this organization. Uses PowerShell, connects, all is good. Jeffrey looks away for 1 minute. He tries to run another command, steal secrets, all that bad stuff. Access denied, it doesn't work. This would be an amazing situation if it could ever possibly work, right? That's what you'd love to be able to tell everybody. And the way to think about your security exposure when it comes to admins is kind of an intersection of two things. On one axis here, you've got the time. So somebody is an admin for a certain amount of time. Anything they can do in that time, potentially bad stuff. Then you've got the capability. That's kind of another way to think about it. While they have administrative access to this system, what kind of bad stuff can they do? Now, like a bunch of us in the industry, we're starting to get our heads around that time access. So privileged identity management, you say, hey, I'm going to file a ticket, make me an admin for the next half an hour or the next hour. Ticket gets filed, you're an admin, life's good, you're happy. So that's one slice here. Just enough administration. What we're talking about today is that other slice. It's around capability. Now you've got a user account. Rather than let them do everything that they could possibly do, run Mimikatz, start and stop processes, services, you just decide, I want you to be able to restart DNS, and that's the only thing I'm going to let you do. Now an extreme example of if it's hard to think about how can I reduce capability for something, one way to think about it is like, you can know when it's done wrong. A great example was, how did an HVAC contractor, those creds, like how do they ever get access to so much sensitive stuff and sensitive networks in the target infrastructure? They should never have had the access or the capability to do that kind of stuff. And in the computer world, for somehow, the invention of the admin account and the root account is one of the worst things we ever did for computer security. When we talk about physical security back thousands of years, it's not one big master key for everything. You've got a key for your mail, you've got a key for your house, for your bike, your nukes, whatever, right? When you want to have a neighbor check your mail while you're on vacation, you don't go, here's all my stuff. You say, here's my mail key. Would you mind going into it a couple days? So we can do this. We've got an approach, right? We can start to incrementally reduce admin exposure. Now, obviously, the thing we preached all the time is reduce your number of admins. Like Bloodhound is a great example of doing that. You know what? Through this attack graph, you actually have 6,000 domain admins because your group nesting is all screwed up. So we got that. We're working on that. Now you can also reduce the duration of the admin privs, right? Then you can also reduce what you can do with those privs. So then you're starting to get into that nice little square spot where that intersection happened. The way we're going to do this is JIA, or just enough administration. So this is based on the stuff that we did originally in PowerShell version 2, which was 2008, in support of Exchange Online. We added PowerShell remoting in 2008, and then Exchange Online took a huge bet on this, and this is their management technique. When you connect up to Exchange Online using your account, you're not like, log in as admin, 123, password, exclamation. No, you got your own account. You get access to your mailboxes and just the commands that your role is allowed to do. So this is battle hardened, it's tried and true. Now, GIA, we base it on 3 simple things. The first is the idea of role capabilities. So GIA is kind of like thinking about it as RBAC, right? So role capabilities, you got the idea of a DNS admin or something else. So the role is just a refined set of commands that you want to apply to somebody who's got a certain task to do. Then you've got the endpoint. When they're connecting with PowerShell remoting, they connect up to an endpoint on the server. It's a PowerShell remoting endpoint. And this is actually the connection point where PowerShell and WinRM makes an identity translation there. You're no longer invoking things on the machine explicitly as you, but it can be under an alternate account. And the key here is that alternate account is way, way more privileged, that you don't have to give the person connecting these full privileges. And this, ultimately, that identity translation results in you get to choose which identity all these things are going to run under. Now, a funny thing when it comes to kind of on the topic of breaches and all that kind of stuff, kind of a reminder sometimes that internet advice is often worth what you pay for it. So here's our good friend Edward Snowden, deciding to give advice on how to prevent breaches. Now, what he points out is correct. Locking down the admin workstations is a great way to do it, but as his little demonstration proved, is obviously not enough. And sometimes you just don't wrestle with somebody because they just love it. Tried to point out that GIA is another great opportunity. This is a good way to start locking down things. And he's like, no, it's totally not going to do anything. Tried to be a little bit more explicit here, like now you can let somebody manage SharePoint without stealing everything. He didn't respond to that one, so I don't know. So let's give a little quick demo of GIA. So like I mentioned, GIA is based on the same ideas. Oh, no, you can't see that, can you? All right. Oh, by the way, look, we can get shells. Look at that, popping shells like a boss. How does that look? Can you read that? All right. So this is PowerShell. This is interactive PowerShell. You can do cool stuff. Now the core point about GIA is using PowerShell remoting. So I'm going to connect up actually to show you first. So here's a simple command to connect up to my domain controller. Authentication works. It's a good thing. Okay, so now I can enter this PS session. This is now PowerShell remoting. You see my prompt change. I'm now just doing regular PowerShell remoting, and I can do the same stuff I used to do. Here are all the processes running on my DC. I can take a look at all my DNS commands. Bunch of cool stuff. Now the situation is, when you want to give somebody access to do DNS maintenance on your machine, it's usually co-located with your domain controller. So what you do is you say, hey, here's an admin cred for my domain controller. You just said you're now a domain admin, when all you want to let them do is like check out DNS caches and all that kind of stuff. It's ridiculous. What I'm going to do now you notice here, so if you saw the first script, I was connecting to the DC. I was connecting using alternate credentials. Those are my actual domain admin creds. I'm just going to connect. I'm a DNS admin right now on this machine. I'm just a regular domain user. I'm not even an admin on my local host, let alone the DC. Now check this out. I can still do the same thing here. Look at this. On the right-hand side, you see the command bar in the ISE already came down to the commands that I'm allowed to run. This is all the stuff that I'm allowed to run when I connect it to the DC. What happened is that PowerShell remoting saw that I'm connecting, applied the DNS admin role capability to me, and now I can do things like show my DNS cache. Oh yeah. So I can do cool stuff. I could not do mimic hats, right? So object, I'm going to do some crazy.NET scripting here. Doesn't work. This GS session has zero access to the PowerShell scripting language itself. All these are commands that have been sent over as data structures and are just being evaluated at the DC. And then when I exit, I'm back to my regular DNS admin. But here's the thing. So my GIA configuration, I set up an endpoints directory. Now I've got a transcript of everything that I just did as that DNS admin. I don't know if you've seen this thing in the ISE. PS edit on a remote file will automatically drag it back and let you open it up in the ISE. It's pretty sweet. So now I can go through and take a look at all the stuff that happened in this session. You can send this thing into a SIM. You can start to do queries against it. You can detect if somebody's... You can detect here if somebody's trying to do bad stuff around you can detect if people are trying to do bad things around PowerShell scripting and other things. You can take a look at them even attempting to break out of their boundaries. So it's super, super useful. So let's start talking about So let's start talking about what makes Gia tick. There we go. So the first thing here is the role capabilities. I talked about how you actually set these things up so that you can restrict somebody to something as simple as like DNS maintenance. So this is literally what a role capability looks like when you configure it with Gia. You've got a description, you've got some modules you can import. A lot of times it looks just like the stuff you're already used to with PowerShell. I'm going to give some visible commandlets. Sometimes when a commandlet doesn't do exactly the job you need, you can also expose some functions, and those functions have full access to the PowerShell language. They don't have the application of all those constraints. Then I can go in and say, well, I'm going to make a whoami function that can then do some stuff with the PowerShell scripting language. So this lets you stitch together things that you might not otherwise want to make available. Then there was that whole endpoint concept. So the endpoint, the major point here is setting the session type to restricted remote server. This is what tells PowerShell that you want to apply the Gia principles to these connections. Here you see that I set up a transcript directory where every connection to one of these things is going to start running transcripts. This run as virtual account, this is a great thing. So there's an idea of virtual accounts in Windows where they're these temporary, ephemeral administrator accounts. They don't have any creds to pop. They're not good off the machine. When you connect with Gia, the person, that Gia session then becomes launched as one of these virtual administrator accounts. So you don't have to worry about that machine getting popped and anything else leaking. And then there's the role definitions. When you connect up to one of these things, this is what PowerShell looks to say, well, when DNS admin connects, I'm going to give them the DNS maintenance role capability. If you have a person that's actually part of several different roles, well, PowerShell will automatically merge these things up for you. Now, the idea of identity, this is kind of an important thing. There's a bunch of different identity types supported. The default that PowerShell does is the connected user. I use PowerShell remoting, connect up to a machine. That process is launched as me. You can set up a named identity. So this is like you give explicit username and password as creds. They're stored in the data protection API. There's some danger to this, but sometimes you might feel that you need it. You can do this for local accounts or domain accounts. There's the virtual account, the virtual administrative account that you can use. This is by far the best when all you need are things like DNS admin, which is just local administration on the box. And then you have group managed service accounts. These are the same things that you have since the earlier days of Windows Server, where you've got basically a domain account where the password is automatically managed for you by Active Directory. So it's rotated all the time. You don't need to worry about password maintenance. You don't need to worry about them leaking. But when it comes to these identities, the point we talked about before is, wouldn't it be great if popping one of these servers didn't leak high-value creds? Sometimes you'll run into a Gia situation where you just need to be an identity going off the box to doing something else. Like, you're just going to need that sometimes. But if you don't need it, always prefer the ones, specifically the virtual account, that stay local to the box. Because the minute any of these identities are trusted off the box, you run a big risk of a compromise of that machine letting somebody squirrel into other machines. And that's kind of the same thing as using RDP to connect up to them. So what actually makes this stuff work? Now the first question is like, why PowerShell? Why are we doing PowerShell for this? There could be so many other ways. And you're like, Lee, you're up there. It's obviously going to be PowerShell. So Gia, think about it like sudo. It's all about controlling what admins can do. So like all shells, PowerShell dispatches commands. You can run exes and all this kind of stuff. Like all shells, you can control which exes are available through ACLs and path and all that kind of stuff. But where it comes really unique is that PowerShell offers the idea of command visibility. So every command that you run in PowerShell, that's contained in something called a run space. When you mark a command as public, well, this command is visible from somebody typing it at the run space level. When you mark something as private, it's no longer available from just typing it at the run space. It's now only available from things that have already been invoked. So I gave that example of a function before, right? That function had access to private commands. The user only had access to the public commands. And that function, you would have made that as a public command. Now, in addition to the whole command visibility thing, one of the magic pieces of PowerShell is that it has access, and it does all the parsing for you. When you write a PowerShell commandlet, you don't go, okay, if $args bracket 0 is a dash and all this kind of stuff. What you do when you write a PowerShell commandlet is say, these are my parameters and they're .NET properties in a C# class. PowerShell does everything else. This parsing is driven off of these data structures, off of these properties and everything else. But the thing is, when we made PowerShell, we made sure that this stuff was open and this stuff was programmable. Now, because you now know explicitly what are the parameters, which ones are available to the users, you can now make proxy commands that take these data structures and start adding and removing parameters, or adding and removing validation on these parameters. When you combine this command visibility plus the ability to manage parameters, that's when you start to really get some crazy stuff. Now, this is what it started to look like. We actually have had this since PowerShell version 1, and this is what it used to look like creating a proxy command in PowerShell version 1. So you see here the first line, I'm going to get the command for get process. The command metadata, you see here, the highlighted one, that's actually the data structure that we use to represent the metadata for a command. I can take that metadata, I can remove some parameters, so I might want to let somebody stop a process by name, not by ID. But then I can take an ID parameter, and then I can also start to add more validation that says, well, I'm only going to let somebody stop Notepad or Calc, but nothing else. When somebody types in these things, PowerShell is going to do that validation before it ever gets to the command itself. And finally, the last step here is we made a proxy command API that says, make a proxy command out of this data structure, which generates a function, and then this function is what you expose to the users. So that's not crazy. In fact, that's pretty amazing. Beats anything I've ever seen in any other shell. But we made it easier in Gia. This is what it looks like in the advancements that we made in Gia. So I showed you the visible commandlets part about the role capability. Those first parts, those are the commandlets that you expose. But here's an example of this. We're exposing the restart service commandlet, and we're saying we're going to only expose the name parameter. And we're going to add a validate set to this that says somebody can only restart the DNS or DNS cache service. They can't go and restart WinRM. They can't go and restart anything else. This is a huge benefit. Now, if you, even I was pointing out before, PowerShell merges these things. If you have multiple of these crazy things, PowerShell will merge those too. So if you're a DNS admin and an IIS admin, and you want to let somebody restart DNS and IIS, you can have those as two different role capabilities, and PowerShell will merge them up. When you connect, you can restart any of those three services. Now here's the thing. When you're starting to create things, you got to think about what your attack surface is when you're doing Gia. You can't just run a Gia script and be like, hey, good days, I'm done. So Gia is restricted to the PowerShell stuff. If you say you harden the heck out of Gia, but then let somebody log in with RDP, well, you really didn't get anything. They just kind of went around. So what you want to make sure you're doing is controlling all the methods of access to the service so that it's all going through Gia. The commands, when you're creating one of these endpoints, the commands themselves they potentially can be dangerous. So there's a good example of the add type command. If you expose that as part of a Gia endpoint, well, the add type command takes arbitrary C#, compiles it, and runs it. So if you expose that to the user, well, they're just going to put in some random Mimikat stuff and be done with it. When you're the one writing your custom functions, you got to remember that these things themselves must be audited, because the commands you expose might have injection attacks or something. So let's talk about what one of those looks like. What we most often see is the invoke expression. People will use invoke expression because they're so used to things like Perl and stuff, where you pack a bunch of stuff into a string, send it off to bash or whatever your command shell is of choice. And command injection is a huge, huge issue in any language that calls commands. It ends up being the downfall of like almost every router that comes out. So the first example on line 1, that's somebody getting the ACL for a specific path. Like that makes sense. But if you don't know the path beforehand, somebody passes it to you as a parameter in a file, this is where you might say invoke expression, get ACL, and then you put in that $ path. So if that's all that path was, like, okay, you're not so bad. But if the attacker decided to put in a semicolon and do other things there, well, invoke expression is just doing what you asked it to do, is run an arbitrary chunk of PowerShell. So what it's going to do is give you back the ACL and then add somebody to the administrators group or something else of their choosing. And the thing is, we knew that this was going to be a danger from the minute we started designing PowerShell. That's kind of the auditing of custom functions, and when you start to get into, well, how do I code defensively to prevent these kind of things? Well, line 1, that's the same as before, get ACL of a specific file. When you don't know a file beforehand, well, you can just use that same variable that you used to use and supply it as the value for a parameter. No matter what you put in there, semicolons, backticks, whatever, PowerShell knows, since it owns the parser, it owns the binder, it's only ever going to provide that as a value to that parameter. Now, sometimes what will happen is you don't actually know the parameters you want to call beforehand. Maybe sometimes it's the path parameter, and sometimes it's the literal path parameter. So that's where you get a function called splatting here. It's this hash table syntax, line number 6. What you do here is you pack up a hash table with the different parameters and their different values, and then send that to the command. PowerShell knows that it's going to apply all the keys and all the values as parameters and parameter values without any danger of injection. The last one here is the line 11 and 12. Sometimes, very rare, but sometimes you don't even know the command that you want to invoke beforehand. And that's where the invocation operator is your friend. You can still store the command name in a string, use this ampersand, which is the invocation operator, and you can combine the invocation operator, splatting, and everything else, and get the ability to run a command that you don't know, parameters you don't know, and arguments you don't know, without any danger of script injection at all. So this is a really important thing to note when you're writing your own functions that are going to be exposed as part of a GIA attack surface. So the next big part, we were talking about creating all these endpoints. And the big thing here is the configurations as they're applied to the server themselves. So when you connect to a remoting endpoint, it's got a couple things you can do. There's a name, there's the ACL, so who's allowed to actually connect to that endpoint? What's the identity that's going to be used when somebody connects up to that endpoint? And then there's the run space configuration. So PowerShell packs all this into something called an initial session state. And in that, you can also define a startup script. So whenever anybody connects up, it'll run whatever script you want, and then you can finally lock down all the commands you want to run. So it's a great way to do more custom things when somebody connects up. So the PS session configuration commandlets are the ones you want to use for setting these things up. So when we put it all together, this is what it ends up looking like when you create a constrained PowerShell configuration. New PS role capability file, that's the way to create a role capability, and that has tab completion and all this kind of stuff for all the parameters and all the commandlets and aliases and all that kind of stuff. You can create a new PS session configuration file, so that lets you configure the mapping of role capabilities and all that kind of stuff at the endpoint itself. And finally, you call the register PS session configuration commandlet to actually make that session configuration active. Now, the one point I would point out is I talked about the name parameter. So the name parameter is awesome. What you actually want to do is replace the default one, which is Microsoft.PowerShell, so that anybody connecting by default to that endpoint, without specifying like a special name or anything, they just connect up with PowerShell and they get the commands that they're supposed to use. What you might want to do is create another one, kind of like a break the glass endpoint, where they can go off and you can give some very specific people the privilege to go off and fix a broken configuration. And there's a ton of things you can do in role capabilities. The ones highlighted in yellow are kind of the most important ones. You're probably not going to run into much about environment variables or types of process or anything. The important thing to recognize is with the command capabilities and the commands that you expose, these can be anything. PowerShell commands work, native exes work, anything that you can automate. And that's kind of the prerequisite for GIA, is that you've already found a way to automate some of your stuff. You're never going to be able to expose through GIA, like restricting where the mouse can go in some sort of menu. So here's all the stuff that goes into a PS role capability file. Session configurations have a bunch of cool things too. The one thing, so there's obviously the session type that I talked about, the run as virtual account. One of the neat things is sometimes you'll need a group so that when somebody is running on a machine, they're not actually just looking, are you a member of the administrators group? Sometimes you need to be a member of an alternate group. And so as part of this, you can set up the run as virtual accounts group when you also specify the run as virtual account. When the person connects up to that machine, there'll be a virtual administrator as part of the local group that you've decided to put them in on that machine. The one important point too is, I pointed out, when you start trying to run commands on one of these things, you always want to do the language mode of no language. You don't want to ever expose the PowerShell language directly because there's just far too much capability in it. One of the cool things that we do too here is we've got the security descriptor CIDL. If you wanted to, you can handcraft this, create the CIDL by hand. You can also show the security descriptor UI while you're creating this thing, and you'll get that traditional Windows picker that lets you say, here are the groups and users that I want to provide access to. Now the cool thing is PowerShell will automatically create this correct CIDL for you when the role configuration, when you specify which users and groups are allowed access, it'll automatically go and create a CIDL out of those users and groups. And that becomes, it won't even allow domain admins to connect up to that. It's very, very whitelisted to what you've exposed in your role configuration. Now, when you start locking things down, it can get complicated. So we've invested a bunch in diagnostics. So the first line you see here, get PS session configuration, that shows me like just checking out what a configuration is like, who's allowed to use things. These have a CIDL attached, like I had mentioned. We have a commandlet now that you can go off and take a CIDL string and convert it to something more human readable. So this convert from CIDL string. So you see here on this one, I allowed the DNS admin access, but nothing else. Now, one of the things you don't want to do when you're creating one of these restricted things is to say, hey, DNS admin, can I have your password? Because I want to like log in and see which commands you have available. They're like just not that friendly. I don't know why. But what you can do here is you can run the get PS session capability. You can give it access to the endpoint name, give it the username or group that you want to test, and it will automatically go and tell you what commandlets would have been applied to that user. Sort of like a what-if mode for applying GIA. The thing is, these startup scripts, they can do anything. You can set up logging. Pipeline logging is a great thing in PowerShell, shows you all commands that are run. If you've got a machine where it's just too noisy to get that set up, well, this is an approach you can do in your startup script to only apply the pipeline logging during this session. And this is a kind of data that you see when somebody's connecting. You can see the command and their arguments. Well, here's a great example too. Maybe you say, whenever somebody connects, I'm going to send a mail. Maybe it's a very sensitive server. Whenever somebody connects, I'm going to send a mail to some box. So I've got automatic logging in an email box or a ticket or something like that for every time somebody connects. Maybe you want to even start to apply some date restrictions. If anybody's connecting in the weekend, you just throw an exception, go home. No connections allowed to this endpoint on the weekend or during a change window, right? And if you're interested in starting down the path of doing the, hey, I want to start restricting time down when people can connect, when they can do the privileged identity management stuff, if you want to restrict that, this is a great way to get messing with it, right? Put a CSV somewhere, do a hacky REST lookup to a ticket system, and make sure that there's a ticket applied to this machine at that time. That's like an afternoon of work to mess around with that, as opposed to going off and spending a huge like sales and whatever engagement to get somebody to tell you that it's going to do the job no matter what. You can mess around and say, this is really doing good things for us. Let's go further down this path. So back to that security exposure question, right? We had time as at one axis, capability as the other. When you bring in the privileged identity management, that gets you some time stuff, or even your GIA startup scripts get you the time stuff. GIA gives you the capability on that cross-axis. When you start combining them both, your attack surface now goes to this really, really small square of just people doing just what they're allowed to do, just when they're allowed to do them. It's pretty, pretty epic. So we got a ton of resources on GIA. We've been working on it for a long time. We got an introduction to GIA on the aka.ms. There's a ton of stuff about PowerShell security and logging in the PowerShell Hearts the Blue Team blog. And of course the PowerShell blog, we've got tons of stuff, always dropping new stuff and new info. So thanks for your time. Any questions? I got stickers, by the way, if anybody wants some. Questions or no questions, I'm fine. I'll give you a sticker anyways. Oh, come on by. They're paper, though. Like, oh, I was like, God, what do you expect me to do? Oh, actually,